Hey everybody, welcome to the Decision Science News R tutorial number 2. Last week we downloaded and installed R, and we saw that it puts it in a folder called bin under R in the program files directory, and the program we used to start up the interactive console was called rgui.exe. Now what I'm going to do is I'm going to create a shortcut to the rgui program, and then I'm going to remove the shortcut from the directory where R is installed, and I'm going to place it in the working directory in which I'm storing my data files and my script files. And this is an important little hack. If you copy the address of your working folder, you can actually modify the shortcut by right-clicking the shortcut, selecting Properties, and if you just change the Start In field here to your working folder, then when R starts, it will automatically look in this directory for data files and script files and things like that. So we'll just fire up R using our modified shortcut. And for instance, if I want to open a script now, it's already looking inside my working folder. It's not looking in the place where R was installed. So I'm going to open up a script file again to save myself the trouble of typing, so you don't have to wait for me to type things. And we're going to look at the basic goal of today's lesson, which is reading in a text file. We're going to read in this text file called pedometer.csv. So here it is. I'm just viewing it in Excel right now. This is data of me actually wearing a pedometer over 88 days. And on each day that I wore it, these days are in order, in temporal order. Each day that I wore it, I recorded the day of the week, and I recorded the number of steps that I took on that day. And I will save it as a comma-separated values file. R reads in lots of data formats, but CSV or comma-delimited file is a very convenient one. Okay, let's overwrite it. Tell it yes, indeed, we do want to save it, and close it. Now, if you have any curiosity about what's in a CSV file, you don't have to view them in Excel. Of course, you can view it in any text editor. So here I can view the contents of that file in the Vim text editor, and you can see what it really does is it separates the columns of data with commas. So here we have the observation column, here we have the day of the week column, here we have the number of steps column, and the header. So it's very simple plain text format that R can use to read things in. So let's read in that data, okay, with this one command. So I just used the command read.table, which can read in various kinds of data streams. I give it here the file name. Notice that I don't have to give it the entire path to the file because of the way that I started R. I hacked the shortcut so it knows to look in the directory in which I'm running R out of for the file. I don't have to give it the whole path. You can give it an entire path if you want to by just copying the path out and pasting it in to your file like so. But there's one thing that you have to, it's kind of a gotcha that you have to look out for, is if you do this, is you have to reverse the direction of all of the slashes because R likes the slashes to go one way and Windows makes the slashes go the opposite way. So if we're lucky, yes, you see that I can read in a remote text file that way just using the slashes. So with this read table command, I've just taken the entire contents of that file and assigned it to a variable called my data. Remember, if we just type the name of a variable, we can see what's in it, and here we see exactly what we saw in Excel. We see the observation number, a column of days, and the column of steps, all held within this big variable my data, which is called a data frame. A data frame is just a bunch of vectors stuck together. So if I want to look at one of those vectors, let's say I just want to see the days of the week, I use the $sign operator here to say I want to look at just the day variable within the MyData data frame, and it shows me the days like that. If I would just want to see the vector of steps, I can look at them like thus. Okay? And as before, remember, I can use any of the basic operators on these vectors, so I can see the mean of the number of steps that way. Great. So now let's do something with these vectors. So we saw that MyData steps is a vector, and here we can use the hist command to draw a histogram of the values. So here's our histogram. Let me just move it in so you can see it. Histogram of the number of steps. If I want to specify the number of breaks in the histogram, so here it's just using the default number of breaks, but I can actually tell it to draw the histogram with 20 breaks, and now you can see it's redrawn the histogram with the number of breaks that I've specified. Now, I didn't have to do this, this was optional, but I decided to assign the output of the histogram command to a variable x. Let's take a peek what sits in that variable. As you can see, we see this familiar $sign operator showing that x actually holds a lot of output related to making a histogram. For instance, it shows you the breaks used to graph the histogram, the number of pieces of data within each of the bins of the histogram, and so on. And to get at those bits of information, I would just do it the same way that I addressed the columns of a data frame. I could just say x $sign counts, and I would get the vector of the counts within each bin, just like that. So that's a nice side effect of the hist command. Okay, basic plot. Remember last week we saw plot x against y. Here we're just going to plot the number of steps taken per day and the day of observation, and we're going to color it blue. So I'll just run that. Go to our graphics window, and here we see the number of steps per day. So let's say we want to test this hypothesis that the longer I wore the pedometer, the more steps I took per day. So just by measuring my own behavior every day, I decided to exercise more and more, or walk more and more. And to do that, we might want to try to fit some kind of trend line or curve to this data, which fortunately is very easily done in R. The basic command we want to look at is lm. If you want help with a command like lm, you can just type $lm, and it will come up with a help file all about the lm command, which is of course short for linear models. So I'm saying, give me a linear model. I want to see the number of steps as a function of the observation number, right? And I'm assigning the output of this regression to another variable that I'll just call my model. I could call it anything. So we run that. You can see here in the command window we've run it, and we don't see anything because all of the output of the command is held in this variable my model. We just type the name my model. We can see the coefficients coming out of the regression, the intercept and the slope. If we want more detail, we can write a summary and then pass it the variable to which we assigned the output of the regression, my model, and then we can see more details about the regression, information about the residuals, the coefficients, t-values, p-values, and so on. Okay. Now, what if we want to graph the fitting line that comes out of this regression? Well, that's easy enough. Now, we already have a plot active in the plot window. So you can see here, if we look at the graphics window, there's already a plot active there. And the command lines just adds lines to an already existing plot. So with this command right here, I can say, I want you to add lines to this plot, and I want that line to be the fitted values coming out of this regression, which I've called my model. So I'll just run that. It shows up here in the console window, and when we look at the graphical output, we can see the regression line drawn there. So it looks to me as though there was an increase in the number of steps per day that I took over the 88 days that I measured my behavior here. And I can go beyond that, fitting, fancier functions such as, let's say I want to look at a lowest line, also spelled Lowess line, to this data, and I'll color it red so it sticks out. Just run that, look at the graph again, and here we see the original data, the regression line that we fit, and then we see this kind of local fitting line. So there we have the second lesson, creating customized shortcuts to start R out of a local directory, reading in an external data file, and doing a little bit more with plotting. Hope you enjoyed it.